Hey guys, this is your trainer Anirudh Chhillar. So I'm back with another video of EIGRP. I hope you're learning in a good way and in good pace. Let's go.
And again it will be classic mode. We will be discussing about classic mode only, not named mode, right? So in previous class I have already discussed about metric calculation in classic mode. So as you know that for metric calculation it will be using two types of attributes, fixed and variable. Under fixed you are having two components, bandwidth and delay. Under variable components you are having load and reliability. Fine. So these four components will be considered during metric calculation in EIGRP, as we have already seen. We have already seen its metric calculation formula, in which we were considering bandwidth, load, delay and reliability, right? And we were also having some metric weight values, metric weights, which are also known as K values. And in classic mode we are having 5 K values: K1, K2, K3, K4, K5, and by default K1 and K3 is equal to 1, and apart from K1 and K3 all others are 0. These are the default K values. And as I have already taught you that in EIGRP to form neighborship it is mandatory that their K values must match. If their K values do not match, then definitely neighborship will never come up in between those two devices, right, where K values are mismatching. Fine. So that's all about the metric calculation in EIGRP. Then after it, let's go for some other things here. Like in EIGRP we must talk about successor, that what is the meaning by successor. We must talk about feasible successor, and of course we must talk about feasible distance, and we must have information about advertised distance, or we can also call reported distance. So successor, feasible successor, feasible distance, advertised distance, and of course reported distance is also there. So you must be remember, you must have this information, that what is the meaning by successor in EIGRP. So of course a best path in EIGRP is always known as successor, and the best path selection will be based on metric only. And here in EIGRP, as you know, that lower metric will always be preferred, right? So a path which provides you, or a path by which you can reach your destination network with lowest metric, will be known as successor, or a path with the lowest metric will always be known as successor. Feasible successor is also known as backup path. Feasible successor is also known as backup path. So one more thing that I would like to tell you here in EIGRP. In EIGRP you will be having three things: successor, which is best path; feasible successor, which is also known as backup path; and possible path is also there. Possible path is also there because it is not always mandatory that secondary link will always become feasible successor. Is not it? It's not mandatory that secondary link will always become feasible successor. It's not mandatory, because to become feasible successor there is a condition which is known as condition of feasibility, and it is mandatory to satisfy that condition. If that condition of feasibility do not satisfy, then definitely your secondary link will never become feasible successor. So of course it will be known as now possible path. See, there will be three possibilities: successor, feasible successor, and third one is what? Possible path. Fine. Successor, you understand very well that what is the meaning by successor in EIGRP. Best path will always be known as successor with lowest metric. Feasible successor, backup path. And to become feasible successor there is a condition which is also known as condition of feasibility. And what do you mean by condition of feasibility? How can we define this condition of feasibility, or what is that condition of feasibility actually? That a backup path advertised distance. I mean, to become feasible successor, backup paths advertised distance, or you can say reported distance, must be lower than to the feasible distance of successor. Because if you talk about the feasible distance, means total metric of successor. A total metric of successor is known as feasible distance. So if you talk about condition of feasibility, so to become feasible successor, a backup path advertised distance, must be lower than to the FD of successor. Feasible distance, you know very well that what is the meaning of feasible distance, total metric of successor. Advertised distance or reported distance, a metric to reach destination from our neighbor. A metric to reach destination from our neighbor, or a metric given by provided by the neighbor router to reach destination network is known as reported distance, or you can say advertised distance, or you can say neighbors FD. A neighbors FD will be known as advertised distance or reported distance. Fine. So this time let's try to understand all these terminologies with using this diagram, a small diagram. This is R1, let's say this is R2, R3, sorry, behind R3, let's say that you are having this prefix 30.1.0/24. This is FA0 by 3 or 0 by 2, whatever it is, but this network is directly connected to R3. So of course R3, not R3, all routers will also calculate the metric of directly connected prefixes as well, for all directly connected networks as well. So whenever you will enable EIGRP on R3 and you will advertise this 30 prefix into EIGRP, then R3 will be creating, or R3 will be responsible to create metric for this prefix which is directly connected to this interface. Understood? So this time let's say that R3 have created its metric which will be known as feasible distance. Let's say it was 100. See, R3 calculated the FD of this directly connected prefix. Now R3 will be responsible to give this update to its neighbor R2 as well as R5. R2 will receive this 30 prefixes 30.1.1.0/24 via R3, and this time its advertised distance will be AD will be FD of neighbor. So what was the FD of neighbor? It was 100, right? So this time its advertised distance will become 100. Its advertised distance have become 100. Now it will calculate its total metric as well, which is known as FD. Let's say its FD have become now 200, right? Now R5 will also receive this update from R3. So it will also say that okay, it can reach 30.1.1.0/24 via R3, and its advertised distance is what? Let's say 100, and FD is also, let's say, 200. Now R2 will give this update to R4. Sorry, R1. R2 will give this update to R1, and R1 will receive this update from R2 that 30.1.0/24 is reachable via R2, and this time advertised distance will become 200 because R2 will give its FD to its neighbor R1. So for R1 it will become advertised distance, and let's now R1 will calculate its FD, and let's say its FD have become now 300. We are simply assuming it, right? So it will become now, let's say, 300. So it have become 300 now, and now R5 will be responsible to give this update to its neighbor R4 as well. So R4 will receive it from its neighbor 30.1.0/24 via R5, and this time its advertised distance will be 200 and FD will be 200. Sorry, let's say it have become 300 now. Then R1 will also give its update to R4 as well. R1 will give this update to R4 now. So when R1 will give this update to R4, so R4 will receive this update that to reach 30.1.0/24 its AD via, tell me R1, AD is going to be 300. Let's say FD have become now 400. So this time R4, try to understand, this time R4 is having two possible paths here to reach this 30s prefix. One is via R5, one is via R1. Via R5 its FD is what? 300. Via R1 its FD is what? 400. So its best path will become via R5. So it will become now successor. Now R4 is also receiving this prefix from R1 as well. It means it can also reach this prefix via R1. So it will try to make it as a feasible successor. But there is a condition to become feasible successor, and which is known as condition of feasibility. So what is that condition of feasibility? That a backup path's advertised distance, which is this time 300, must be lower than to the FD of successor. And what is the FD of successor? 300, which is equal to advertised distance of backup path. So even it is equal to the, even if your advertised distance is equal to the FD of successor, then also it will not become feasible successor, because to become feasible successor, a backup path's advertised distance must be lower than to the FD of successor. But this time it is equal to the FD of successor. That is why it will not become now feasible successor. Say because for R4 it have not become feasible successor, so R4 will also give this update. It will also advertise its best path information towards R1. So R1 will also receive this 30.1.1.0/24 via R4, and advertised distance will be FD of will be FD of R4, so it will be 300 once again, and now it will calculate its FD, which which will become 400. So now R1 is also having this information that it can reach this 30s prefix via R2 as well as via R4. Lowest metric is via R2. Its best path will become via R2 itself, so it will become successor. Now, of course, R1 can also reach this prefix via R4 as well, but again, condition of feasibility must be fulfilled, must be satisfied. So, condition of feasibility says that backup path's advertised distance must be lower than to the FD of successor, but again, it is equal to the FD of successor. So, for R1 also, you will not find any feasible successor. For R4 also, you will not find any feasible successor. It means any router will not have feasible successor for these 30s prefix. Now, tell me, in case if R1 successor goes down, will it not be possible for R1 to reach now 30s prefixes via R4? It will be. It will be. It means it will become now possible path. Possible path. Hey, R1 is having a possible path. So there will be three types of paths: successor, feasible successor. Third one is what? Possible path. Understood or not? So in this way, your successor, feasible successor, possible path will be defined. Now question is that why do we have this condition of feasibility?
To avoid loop.
To avoid loops. Of course, there can be a routing loop in your EIGRP domain if you do not follow this condition of feasibility. Even we can prove it. Like in this way. For an example, this is R1. This is R3. Forget about split horizon for some time now. Let's say that split horizon is disabled here in this network, right? And there is a 30s prefix 30.1.1.0/24. It will give this update to, let's say its FD is what? By default 100. For directly connected prefix, R3 have calculated its metric as 100. So R3 will give this update to R2 now that if you want to reach 30.1.0/24 via R3, then your AD is going to be 100. Then it will calculate its FD. Let's say it is 200. So R2 will give this update further to R1. So R1 will receive this 30s prefix now via R2. And its AD will become now 200. Let's say its FD have become 300. Now, mistakenly you disabled split horizon on R1's this interface, right? So if you have disabled split horizon here on R1's this interface, so R1 is going to advertise this information, this update back to the R2, and R2 will receive this update from R1 as well, and this time R2 will receive this prefix in this way 30.1.0/24 via R1. AD will be 300. It can calculate its. So if there is no condition of feasibility, then it will think that okay, this is what feasible successor, and it will be successor. Is not it? If there is no condition of feasibility, if we do not use that condition of feasibility in EIGRP, then of course this path will become feasible successor. Now in case if it goes down, then R2 will think that okay, it is reachable via R1. Even it will not generate any query message, and if it does not generate any query message towards R1, it means that R1 will never come to know that it has gone down. So R1 will be having this route, will keep this route via R2 in its routing table. R2 will keep this route in its routing table via R1. So there will be a routing loop now, because if you transmit any packet from the lane of the R1 towards 30's prefix, R1 will give this packet to R2, because R1 was learning this prefix via R2, and R2 will receive this packet, will transmit it back to R1, because R2 is receiving this prefix coming from R1. Is not it? So that is why this condition of feasibility is mandatory, because if you are using here condition of feasibility, it will never become feasible successor. Fine. Let's talk about types of packets. Hello is there, update is there, acknowledgement, query, reply. You know very well that what is the uses of hello packet in EIGRP? Just to discover your neighbors and to maintain neighborship. Update, just to give the update, just to give the route's information to its neighbor device. One more thing, that here in EIGRP it will send triggered updates only. It means there must be some reliability. There must be some reliability. That is why remember that update, query and reply, these three packets will be using RTP, reliable transport. It means that for all these three packets it is mandatory to receive an acknowledgement back. Let's say if you have given any update packet to your neighbor, then it is mandatory to receive an acknowledgement back from the neighbor. Even if you have given any query message, if you have forwarded any query message towards your neighbor, then it is also mandatory to receive an acknowledgement back from that neighbor for which you have generated your query message. Reply, for reply also you will be using RTP. It means if you have given reply message to anyone, to any neighbor, then it is also mandatory to receive an acknowledgement back from that specific, that particular neighbor. Any problem? Fine. Now remember that for acknowledgement and hello packets there will not be any acknowledgement. Hellos are not reliable, even acknowledgements are also not reliable. Any problem? Fine. And here there is compulsion to have an acknowledgement only for these three types of packets: update, query and reply, not for hellos, because hellos will be generated by EIGRP periodically in every 5 seconds by default. So if you are transmitting an information periodically, then of course you will never require to have an acknowledgement for that information, for that packet, for those packets. But if you know, like, you are not going to transmit packets periodically, you will transmit your packets only once, then it is mandatory for you to have an acknowledgement. Because what if that packet was dropped somewhere in the network, was not delivered successfully? What will you do? It means that your neighbor can have sort of information, and if your neighbor is having sort of information, due to that sort of information there can be a routing loop. It's not it? Are you getting my point or not? So to prevent your network from routing loops, of course it is mandatory to have an acknowledgement for these packets like update, query and of course reply as well. We know very well that what is the uses of update. We know very well that what is the uses of acknowledgement. You must be having this information as well, that what is the uses of query message. Remember that whenever a successor will go down, it will always generate a query message towards all other neighbors. That you have any information of this prefix. Let's say this is R1. R1 was learning one prefix from this direction on this interface. It has gone down now, so R1 will generate a query message towards this neighbor now. That do you have this information? Do you have any information about this prefix? So now query will also transmitted by router only once. It will not be generated by your router periodically. That is why it is mandatory to receive an acknowledgement back from the receiver. So whenever your neighbor will receive this query message, it is mandatory, it is compulsory for this router now to generate a acknowledgement back in the response of query message. Yeah, reply will also be there, but apart from reply, you are also having an acknowledgement as well. Now, if this neighbor is having an information about that prefix, then definitely it will provide reply message that yeah, I'm having this information in my topology table or routing table, so you can also reach this prefix via me as well. Are you getting my point or not? So in case if this router does not have any answer for this query, then definitely this router is not going to generate any reply message. So reply will be generated by router only in that case when it is having information about that prefix for which it received query message. Fine. And one more thing, if your router have generated any query message and if it does not receive any reply, whether it was negative or positive, because if it receives a negative reply means it does not have any information about this prefix. But if it receives positive reply that yeah, you can also reach me, you can also reach this prefix via me, then of course this R1 will install that route in its routing table via this neighbor. But in case, let's say R1 didn't receive any reply for that query which it have transmitted in the direction of this router now. So there is a rule that if you have transmitted a query message, it means you will become active. It means you have become active for it. Just after, actually query will be generated by your device whenever it will become active for your prefix. Because there are some states like active, passive. So if your device, if your EIGRP is in passive state for any prefix, it means there is no problem related to that prefix. But if your device have become active, it means exactly, it means its successor has gone down. Because whenever successor will go down, if it does not have feasible successor, it will always become inactive. And whenever your router will become an active router for any prefix, it will immediately start to generate query message. And remember, it will remain inactive until it receives reply. But if your router do not receive a reply packet from its neighbor in the response of query message till 180 seconds, 180 seconds, then it will announce itself in stuck in active state. Then it will not be in active state, it will become in stuck in active state. And once your router will become stuck in active state for any specific neighbor, then after 180 seconds, after the expiration of active timer, because by default active timer is 180 seconds. So after expiration of active timer, your device will become stuck in active and immediately it will break neighborship. It will reset neighborship actually with that neighbor. That is also known as stuck in active state. In a stuck in active state, your router will always break neighborship. Understood or not? Fine. Now whenever your router will receive any reply, then again it has to give an acknowledgement back to the sender. Fine. Is there any problem now about all these packets? Sometimes all these packets will be unicasted and sometimes some of the packets will be unicasted and multicasted. Like hellos will always be multicasted by default unless you configure static neighbor. If you have configured your neighbor statically, then of course your hellos will also be unicasted. Of course, after configuring your neighbor statically, then your hellos will be unicasted, but by default they are multicasted. Update packets. First time by default it will unicast update packets, and then after it will multicast your update packets. But if you have configured your neighbor statically, then it will always unicast its update packets. Remember, there are two different conditions. First condition in which you have not configured your neighbor statically. So if you have not configured your neighbor statically, then very first update will go unicast, and then after all other updates will go multicast. But if you have configured your neighbor statically in EIGRP, then it will always send its update packets as unicast packet. Will never use multicast address to send its update packet. Third is acknowledgement. Acknowledgement will always be unicasted, because acknowledgement will be given to that neighbor only from where you received update packet or query or reply. That is why acknowledgement will always be unicasted. Query will always be multicasted by default, but if you have configured your neighbor statically, then query will also be unicasted. Reply will always be unicasted. Reply will always be unicasted. Nishit. So there are two different conditions in which, in one condition you have not configured, you will not configure your neighbor statically, so they will form neighborship dynamically. In another condition you will configure your neighbor statically, so after configuring your neighbors statically, then they will send all types of packets as unicast packet. Fine.
So that's the end of today's video, guys. So we'll be coming back with few more videos of EIGRP. I hope you learned something new today. So if you like this video, please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you later.